everyone, this is the 15th learning material in the lecture series of Programming in C language. This is our third module. Getting started in subsection that we will be discussing is operators. Let's begin with the module. Friends, to learn about different types of operators in C, we must understand the term operator first. An operator is a symbol that tells the compiler to perform specific mathematical or logical operations. C language is rich in built-in operators. Let's start the learning from a very common type of operator in every programming language, that is arithmetic operators. The symbol that operates on a certain type of data type in order to perform some arithmetic operation are called arithmetic operators. There are total of 5 arithmetic operators in C language. Those are listed in the table. For addition operation, we use plus sign operators in C. For subtraction operation, we use minus sign operators in C. For multiplication operation, we use star sign operators in C. For division operation, we use slash sign operator in C. For modular division operation, we use percent sign operators in C. The modular division is a specific type of integer division which returns the remainder after the division of the answer. It is one of the important operators and operations. Let's understand how the C compiler solves the arithmetic operations. For that, we must understand the very basic rule for solving any mathematical operation, that is BODMAS. The arithmetic expressions are solved by the C compiler by following the BODMAS rule of precedence. Another important part is the order in which consecutive operations within the same precedent group are carried out. This is known as associativity. In the C language, the associativity is left to right. In case of the operation with equivalent precedent, the leftmost will be executed first. The order of execution from first to last is shown in the table. The dashed box shows the group of the precedents. Each contain the operation of equal precedence. Friends, let's move on and learn about another type of operators which we may use is cast operator. The symbol that operates on specific data, certain type of data type in order to change the data type temporarily is termed as cast operator. The value of an expression can be converted to a different data type if desired. To do so, the expression must be preceded by the name of the desired data type enclosed in the parenthesis. The process is called casting process. Let's see the syntax for using cast operators in C. Syntax: in opening and closing bracket data type and then identifier. Now let's actually get the hands down on the programming. For this entire section, we will be following some common outline. In this activity, programmers have the freedom to choose any of the apps from the downloaded 2 apps. Depending on the apps, there are 2 different outlines. For all the programs that we will be discussing in this section, the lines written in the red color will be the same and is necessary to write for each program. Only the black colored line will be different as per the requirement. Let's see the syntax for using arithmetic operators in C. Syntax: identifier space operator space identifier, or identifier space operator space constant, or constant space operator space constant. In opening and closing bracket data type and then identifier. Here, let's try to understand the use of arithmetic operators with the help of few examples. Let's see the first example where we have used the arithmetic operator for addition and subtraction operation. In this particular example, we have enter 2 integer number of our choice and perform addition and subtraction of those 2 numbers. We have initialized the integer type of location with name capital A, capital B and ans. For the interactive type of programming, let's display a statement which will describe that what type of data that the user should be feeding to the computer. In our case, we want to give the 2 integer number, that is capital A and capital B, as input to the computer. Then we have used the command of scanf. In this command, whatever the computer will be accepting as the input is written in the double quotes and then separating with the comma. We have mentioned the location where that data has to be stored. In scanf, we have defined the data type for the integer. Scanf can take number of inputs in single command at the same time. For that, we need to use the space bar between the 2 or more data type identifiers present in a double quote, but we have to use separate commas for specifying the memory locations. To perform the addition and subtraction of the 2 numbers, we use the arithmetic operators plus and minus. Here we will use the ans location to save the answer of the 2 operation. Let's display the contents present in the location ans. Since we have saved the addition and subtraction of the 2 numbers in the ans location, the displays answered must give us 2 different values, one for addition and second for subtraction. Let's enter the value of 2 integer number as 9 and 7. The displayed answer is 2 for addition and 2 for subtraction. But why it is so? In the printf command, we have asked to print the ans 2 times, but as we can see before the printf statement, we have written ans is equal to a minus b. So the computer will execute this command as at last and will replace the previous value in the ans memory location by the new value. So the previous value in the ans location was 16, which we get from the addition of the two numbers, that is ans is equal to a plus b, which is replaced after the execution of the last command, that is ans is equal to a minus b. These are some crucial points we need to consider while writing any program. Let's see the next one. Here also we have defined three locations, all under integer data type. In this program, we are going to perform addition, subtraction, multiplication and division of the two numbers using the arithmetic operators. To avoid the mistake done in the last program, this time we will use the output function printf for each arithmetic operation. For this particular program, since we want to print the addition, subtraction, multiplication and division of the two numbers, we will use 4 printf statement with proper syntax. Let's enter the value of two integer number as 9 and 2. The displayed answer for the respective arithmetic operations such as addition is 11, for subtraction it is 7, and for multiplication it is 18, and for division it is 4. One thing you will note here, student, is that if you divide 9 by 2, the answer will be 4.5. But the answer given by the computer is 4. Why it is so? Because we are feeding the input as two numbers which is initialized as integer data type. Even if answer is 4.5, but the computer will calculate the division as 4. If you want to correct your answer, you have to put the two numbers in float data type and then print the answer. Now let's take another example. We have initialized the three integer type of location with name small c, small d, rem, and three float type of location with name small a, small b, and div. In this program, we are going to see how to use the modular division type of arithmetic operator. Here first we are going to perform the division of two numbers. The two numbers are entered as input to the computer, which are saved in the memory location with the name small a and small b. Then division of the two numbers will be saved in the memory location with the name div. The second operation we are going to do is modular division. The two numbers are entered as input to the computer, which are saved in the memory location with name small c and small d. Then remainder left after the division of two number will be saved in the memory location with the name rem. Now let's take an example where we will apply the previously explained BODMAS rule used for solving the complex mathematical operations. We have initialized the 4 float type of location with name capital A, capital B, capital C, capital D and ans. In this program, we will enter the 4 real value number as input using the input function printf and scan those values from their respective memory location. Then we will execute the next command, which is a mathematical operation consisting with number of mathematical operations such as addition, multiplication and division. To execute this program, computer will follow the BODMAS rule. The respective answer will be saved in the memory location with name ans. If you carefully observe the output command inside the printf statement, we have used it in two different ways. In the first printf statement, we have used only %f, whose simple meaning is that we want to print the answer whose data type is float. That's why we usually use the character f for it. But in case you want your answer very specific, that is you want to have a fixed number of digits after the decimal point, you can do that using that much value in between % and f character. For example, in the given example, the actual answer saved in ans memory location is 18.500000. If you want only 2 digits after decimal point, we can use or type %5.2f instead of using only %f in the printf statement. So this will give us output 18.50. That means we are taking only 2 digits after the decimal point. Now let's understand the significance of using cast operator in C. Let's understand this with the help of example. We have initialized the two integer type of location with name capital A, B, and one float type of location with name ans. In this program, first we enter the two number as input to the computer, which are saved in the memory location with the name capital A and capital B. We have to perform the division of these two entered number and save it in the memory location defined under float type of data as ans. Here, to understand the meaning of cast operator, we have used the output statements. In the first printf statement, we have simply printed the answer as float. In the second printf statement, we have used cast operator. As we have discussed that cast operator is used to get the answer in desired data type format, so we have used float inside the opening and closing bracket before A and B. Now in this case we will get the answer as 4.5 6 times 0. As we have seen in one of our example that feeding the computer with integer input and performing division will not give us the exact correct answer because the computer will calculate the division as 4.00000. But for our convenience we can temporarily print the output in correct format using the cast operator. Use the app and IDEs to write and run the programs discussed in this section. Here we have finished the hands-on part of this subsection.